All right, let's get it. Today, I am going to discuss prehistory and dinosaurs and a few things associated with the like. And it's interesting to me at least, right? I mean, how I came up with the idea of this video. And it all starts with the term prehistory, because I've never actually knew what the term meant. If pre being the prefix meaning before, and then history is documented accounts. I always thought, how can something be prehistory or prehistoric? And then it sort of made sense to me that it is actually, well, let's just get into it. Let's just read what prehistory means. Well, before we get into that, I want to read the definition of a theory, because there are a few things that I want you to keep in mind as I go throughout this presentation, as I go throughout this video, that a lot of the data that will be presented will be a theory. So let's read the definition of theory. And it reads: a plausible or scientifically acceptable general principle or body of principles offered to explain phenomena. 2. A belief, policy, or procedure proposed or followed as the basis of action. 2b, an idea or hypothetical set of facts, principles, or circumstances often used in the phrase in theory. 3, a hypothesis assumed for the sake of argument or investigation. 3b, an unproved assumption, conjecture. 3c, a body of theorems presenting a concise, systematic view of a subject. 4, the general or abstract principles of a body of fact, a science, or an art. 5, abstract thought, speculation. Read between the lines. A theory is not proven science. I'll repeat that. A theory is not proven. It's a hypothesis. It is speculation. It is a guess. Please keep that in mind as we move throughout this video. It is very important. So now let's get into that prehistory definition. And this is from history.com. And I'll try and put all of the links to all of this information in the description. But if not, you'll see on the screen all of the websites that I visited to oh man, what's the word I'm looking for? I had a brain freeze moment there. Um, all of the sites compiled to present this information or to make this video. So, prehistory, the vast period of time before written records or human documentation, includes the Neolithic Revolution, Neanderthals, and Denisovans, Stonehenge, the Ice Age, and more. So, like I was saying, prehistory is basically things that occurred before there was any written record. No one documented these events. So in my mind, prehistory is all speculation. If no one was there to document anything, do we actually have evidence or proof that these things occurred? Right? Here's something to consider also going forward throughout this presentation. Let's talk about data and databases and how a database actually works, right? Because someone will say, well, you can plug this into a computer model and this is how they get carbon dating, et cetera, et cetera, et cetera. You have to have source data in order for these computations to be made. You have to have accurate source data. So if your source data is flawed or inaccurate, there is no way anything it produces is accurate. You have to have a source. Keep in mind that there is no source for a lot of the data that they use to confirm these things. It's all speculation. Why? Because prehistory. No one was there to document anything. So they're guessing. See what I'm saying? Let me give a better example. The last few years, AI has been all the craze, right? It's been a very popular topic of discussion, and a lot of people are talking about these AI generated songs, and whether it's right or wrong, that's another argument. Or you're talking about this AI generated art. Here's the thing with that. It has a source, right? You can get an AI generated song of Tupac because it has Tupac's original voice, his style, as a source. Without a source, without Tupac's real voice, AI would not be able to generate anything. It would give you an unknown source error. You see what I'm saying? At this point, because AI does not have a conscience, at this point, AI is only as good as the computer programmer that created it. It has to have source material. That's very important as we go throughout this discussion. You have to consider that there is no source material because no one was around to verify any of this. You see what I'm saying? See, it's like those AI generated pictures of Jesus and they're all white because of the source data is tainted. That's why. See how this works? Keep that in mind as we move throughout this video. So there will not be a lot of visual stimulating images. I really want to just focus on the data. So I'm not going to have music playing in the background. I'm just going to focus on the data. Like I said, I didn't spend a lot of time trying to create visual aids. I'm just going to go straight through the data. I'm going to try and do it as quickly as possible and try and keep this video from being hours long. So there's going to be a lot of reading, and I only ask that you watch to the end. That's all I ask. If this subject interests you. If it doesn't, hey, cool. Move on to something else. But if this subject interests you, please watch to the end. Please keep an open mind. Please pay attention to the data that's being presented. So the next topic that I want to move into, and this is from the National Historic Museum. And like I said, I'll try and post the links in the description. You can go through and read this whole article if you choose to do so. It's pretty long, but I'm just going to hit on a few points. 66 million years ago, dinosaurs had the ultimate bad day. With the devastating asteroid impact, a reign that had lasted 180 million years was abruptly ended. This article is by Professor Paul Barrett, but he is basing a lot of his article off of Walter Alvarez. Walter Alvarez is pictured at the bottom of the screen with his son. Did an asteroid kill the dinosaurs? In 1980, Nobel Prize winning physicist Luis Walter Alvarez and his geologist's son Walter published a theory that a historic layer of iridium-rich clay was caused by a large asteroid colliding with Earth. The instantaneous devastation in the immediate vicinity and the widespread secondary effects of an asteroid impact were considered to be why dinosaurs died out so suddenly. Okay. I'm going to scroll down and read another part of this article. And again, if you want to go through and read this whole article, you can if you choose to do so. Why did dinosaurs go extinct? Around 75% of Earth's animals, including dinosaurs, suddenly died out the same point in time. So how was this global mass extinction caused by a rock hurtling into the coast of Central America? Paul explains, the asteroid hit at high velocity and effectively vaporized. It made a huge crater, so in the immediate area there was total devastation. A huge blast wave and heat wave went out and it threw vast amounts of material up into the atmosphere. It sent soot traveling all around the world. It didn't completely block out the sun, but it reduced the amount of light that reached the Earth's surface. So it had an impact on plant growth. So let's just unpack some of this. Let's read between the lines of what he's really saying, right? First, he's saying all animals didn't die. He's only saying 3/4 died. And if you continue to read down in this article, it talks about some birds, excuse me, some birds that survived this catastrophic event, so on and so forth. But the asteroid was so hot it was so hot that it vaporized. Creating this event that threw soot and dirt and all of this material into the air that caused life to basically cease to exist. Now, keep in mind what he's saying here. If there was enough soot and enough dirt and debris in the atmosphere that it could change the temperature of the earth, it can change the amount of light that was getting to the earth. It had to be pretty thick. So doesn't that mean that the air quality should be non-existent at that point? Shouldn't it be impossible to breathe at that point? See, and I'm going to do this throughout the video. I'm going to present questions that we should ask when they present this information as fact. questions that they can't answer. So if there were large birds, they would still need oxygen to breathe. So shouldn't they have died with everything else? If the plant life was affected, what did those birds eat? Wouldn't the water have also been contaminated at that point? So what did they drink? See, sometimes you just have to apply common sense to some of these things. Don't just accept what they're giving you. Always question the information. And if it checks out, cool. But if it doesn't, then ask more questions. And keep asking questions. Because eventually, if they have any academic integrity, they're going to tell you that they just don't know. And there lies my problem, is they try and present these things as facts when really they just don't know. But I want you to keep this slide in mind. This is also from the same article, and I'm going to read this paragraph on the screen. What survived the asteroid impact? And this is going to talk about the bird surviving. During the Cretaceous extinction event, plants were less affected than animals because their seeds and pollen can survive harsh periods for longer. After the dinosaurs' extinction, flowering plants dominated Earth, continuing a process that had started in the Cretaceous and continue to do so today. But all land animals weighing over 25 kilograms died out. That's like 52 pounds, by the way. A kilogram, 1 kilogram is equivalent to like 2.2 pounds. So that's why I'm saying it's like 52 pounds, somewhere in that vicinity. What we're left with are basically the seeds of what we have today. Many of the major animal groups that are alive today were in place before the asteroid impact, and they all suffered some level of extinction. But the lines that led to modern animals got through, says Paul. I'm confused, Paul. Did they go extinct or did they survive? I don't think it can be both. I don't think that's how extinction works. Let's continue. All of the non-bird dinosaurs died out, but dinosaurs survived as birds. Some types of birds did go extinct, but the lineages that led to modern birds survived. Initially, the survivors were small, with the birds the first to experience evolution to larger sizes. There were a couple of lineages of gigantic birds, predatory and herbivorous, but they weren't around for very long and also went extinct. So basically, he's saying the large, gigantic birds that were predatory slash carnivorous and birds that ate plants weren't around for very long, as they also went extinct. Which again is why I was saying the plant life would have been contaminated. But everything would have been contaminated, right? If there is enough soot and debris in the air to block out the sun or almost completely block out the sun, everything would be contaminated. And plants don't survive without sunlight, right? It's not how plants work. So you have no oxygen and you have no sunlight, or very little sunlight, and yet we're to believe that something survived this so-called event, right? Which also, if you read between the lines, goes into the ice age, because the sun wasn't able to provide the earth with heat because of this soot and this debris. So the earth got very cold during this period. I think that's a stretch, but maybe I'll do another video discussing the ice age. I'm going to now talk about fossilization, because this is what they tell us are in museums, are fossils. And this is from AustralianMuseum.com. I'm not going to read all of these different kinds of fossilization processes. I literally just am going to focus on the first one, which is permineralization. And it reads, permineralization occurs when dissolved minerals carried by groundwater fill up space inside the cells of plants and animals. The dissolved minerals crystallize in their cellular spaces and eventually form rocks in the shape of the animal or plant. This is the most common type of fossil preservation, and examples include teeth, bones, shells, and wood. We may refer to these fossils as having been petrified. I'm going to read that last part again. I stumbled over too many words. Actually, I'm going to read all of it again. Sorry, y'all. Permineralization occurs when dissolved minerals carried by groundwater fill up space inside the cells of plants and animals. The dissolved minerals crystallize in their cellular spaces and eventually form rocks in the shape of the animal or plant. This is the most common type of fossil preservation, and examples include teeth, bones, shells, and wood. We may refer to these fossils as having been petrified. This is what most dinosaur quote unquote bones that they find. This is the process that they go through. This is how they become fossils. This is how they remain, so-called remain, for millions of years. I mean, because organic material decomposes, and we all know this. So in order to explain away the decomposition process, they have to say that bones become fossilized, which is what you quote unquote see in museums. And I'll get to that later. I'm just trying to lay out their arguments. But this is how we get dinosaur bones, because they become fossilized. And if you read down, and again, if you choose to read the rest of that, you can. I'm not going to. But if you read down into part 3 where it talks about amber, this is where they say insects or bugs are preserved in amber, which is what they used in Jurassic Park. If you guys remember that part of the movie, they had the bug on the top of the guy's cane. The bug was trapped in the amber. That's what that was, which is what they used to recreate the dinosaurs of Jurassic Park, right? So that's what that amber refers to, is the bugs. And in the movie they extracted the blood DNA from the mosquito, whatever, and that's how they created all the, yeah, very far-fetched when you think about it in reality, but that's what it's sort of based on, right? That's the premise, that's the idea. I'm going to lead into the next part of this paragraph, and this is also from the same website. And let's read starting at the beginning. The fossil record refers to the record of life on Earth that has been preserved, discovered, and studied by paleontologists. But the record is incomplete and is often skewed in favor of some organisms over others. Is that an admission? I'll let you decide. For example, by far the most common fossil remains are those of shelled invertebrate creatures such as snails, corals, and clams that live in aquatic environments. Fossils of terrestrial land-based organisms are much scarcer than those that live in aquatic environments. In order for these terrestrial organisms to become fossilized, they must either become buried in an aqueous environment like a lake or a river, or become buried in ash, which would occur during a volcanic eruption. Because of this, most terrestrial organisms never get the chance to become fossilized. There may be whole groups of terrestrial organisms for which no fossil record has been discovered. But this means there are many more discoveries to be made about the history of life on Earth. So we continue to investigate, explore, and uncover the puzzle that is Earth's fossil record. Did you catch it? Did you catch what it said? Because of this, most terrestrial organisms never get the chance to become fossilized because of the decomposition process. And not just decomposition, right? I mean, there are so many like miraculous things that have to occur or not occur in order for this to happen, right? So keep in mind, we're talking 65 million years. No one buried these dinosaurs, right? Which mean they would be exposed to the weather for years and years and years. Extreme heat, extreme cold, rain, harsh winters, wind gusts, etc. That would all have a negative impact on the remains of a carcass, on the remains of said animals. Wouldn't it? I mean, just think about that. No other animal during that period got hungry and, wanted to take one of the bones with them for a snack later, or, whatever the case may be. I mean, there are so many miraculous things that has to occur. Very unlikely. Very, very unlikely. But let's keep reading. Because my next question becomes, can matter change its composition? Can it change its properties? Let's see what BGS.ac says. Petrification, the most common method of fossilization, is petrification through a process called permineralization, which we just read about on the last slide. After a shell, bone, or tooth is buried in sediment, it may be exposed to mineral-rich fluids moving through the porous rock material and becomes filled with preserving minerals such as calcium carbonate or silica. Eventually, the minerals entire oh, I'm sorry. Eventually, the minerals entirely replace the organic material and the remains are literally turned into stone or petrified. So let's unpack this a little bit. According to this article, a bone absorbs water that has traces of other minerals. And this is how you get a fossil. So what you have is the shell of a bone, right? You have the casing being filled with water and other materials, and it eventually turns into a rock over time. But as this bone shell is absorbing this water filled with minerals, the bone doesn't lose its shape. So it's absorbing this water and materials evenly. There is no expansion as it takes on this water filled with these minerals. See, I mean, because things just don't work like that, right? Think about a sponge. When you put it in water and it absorbs the water, it expands. The weight changes, right? When you lift the sponge out of the water, it droops, it sags because of the weight that it's taken on. And when the sponge dries, it contracts. Right? So even if you put a sponge in cement, initially while it was wet, it would still expand. And when you took it out of the cement, as it dried, it would contract. Correct? So how are these bones perfectly intact? No type of deformation. Another question that we need to ask. Keep that question in mind though. I may present an answer later. There is also something that I want to touch on while I'm thinking about it, and that is the freezing process. Because someone's going to say, oh no, they find a lot of things that are encased in ice, and that's how they lasted. The freezing process does not stop the decomposition process. It slows it down, but it doesn't stop it. It doesn't negate the process. See, even encased in ice, organisms are still going to decompose. They're just going to decompose slowly. But when that organism is thawed, that decomposition process is going to be very, very quick. It's going to decompose fast. because the process does not negate it, right? Listen, I love Marvel, but their science is wrong, right? Being frozen in ice for 70 years would not have preserved Captain America to the point that he was still Captain America years after he thawed. He would have aged very quickly once he came out of that ice. His body would still have broken down at a rapid pace. You see what I'm saying here? What about the woolly mammoth? Well, let's talk about the woolly mammoth, right? Which I have my doubts about. But they date that woolly mammoth back, what, 40,000 years? $40,000 compared to 66 million is a huge difference. Think about it in terms of money. $40,000 is no comparison to $66 million. Some of us have cars that cost $40,000. That would be very, very small in terms of percentage to 66 million. So those two things are not even comparable. And like I said, I question the woolly mammoth, but 40,000 compared to 66 million, that's not even the same conversation. It's not in the same ballpark. Please just consider these things when they present you this data. Question it. Ask common sense questions. Continuing with the idea of matter changing its properties or compositions. I'm going to start at the top and read extensive properties. Extensive properties, a physical property that will change if the amount of matter changes. Mass, how much matter in the sample. Volume, how much space the sample takes up. Length, how long the sample is. Physical change, change in which the matter's physical appearance is altered, but composition remains unchanged. A physical change takes place without any changes in molecular composition. The same element or compound is present before and after the change. Let's read that again. A physical change takes place without any changes in molecular composition. The same element or compound is present before and after the change. The same molecule is present throughout the changes. Physical changes are related to physical properties since some measurements require that changes be made. The three main states of matter are solid, liquid, and gas. Basically, it's saying that if it was a rock at first, it would still be a rock. If it was a bone at first, it would still be a bone. Go back a few slides when it was talking about fossilization, and it was saying that the minerals replace the materials and it become a rock. This isn't me. This isn't my data. This is their data. They're conflicting with each other. Again, the truth checks out. The truth doesn't change. Why are there changes? Why isn't this data all adding up? Why are there questions? These are the things that we have to keep in mind when we have this debate. But again, I don't want you to just take my word for it, right? Let's see what the Field Museum has to say about it. Understanding fossils and casts. Fossils form over tens of thousands up to hundreds of millions of years. But fossils are rare since the conditions have to be right for them to form. First, sediment like mud or sand covers an animal's body, and the soft tissues rot away, leaving behind the hard tissue, teeth, and bones. Over time, the sediment hardens into rock encasing the bones, often distorting them. That's what I was just saying. Minerals from the surrounding groundwater and sediment very gradually replace some of the bone's original minerals. This is why fossils are a variety of different colors. They take on the color of the minerals in the earth around them. A fossil can also be a preserved imprint like a footprint or a leaf. And that's a different kind of fossil. I'm not discussing that in this video where something leaves an imprint. Whatever. Again, not the topic of this discussion. Casts are made using precise modes of fossil bones and are one of the most accurate and common forms of 3D duplications you will see on display at the Field and other museums. Whoa, 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 whoa. What did you just say? Let's read it again. Casts are made using precise modes of fossil bones and are one of the most accurate and common forms of 3D duplication you'll see on display at the field and other museums. Other methods include 3D prints made from CT scanning, surface scanning, and photogrammetry. If there's a missing bone in a skeleton, sometimes that shape will be carved like a sculptor. This isn't as accurate since it doesn't come directly from the fossil bone. It is based on examination of existing bones or on references or photos of bones from other specimens that are the same or related species. They're telling you what they do in museums. They're telling you that they're fabricated. Those are not my words. I didn't write that article. Let's continue. In some cases, scientists haven't yet found a particular bone from a certain species. They very rarely unearth an entirely intact dinosaur skeleton. Scavengers can disturb decomposing bodies, and erosion after fossilization may destroy some of no, I'm sorry, let me read that again. Scavengers can disturb decomposing bodies, and erosion after fossilization may destroy some or most of the bones before they are discovered. It's from the Field Museum. That's not me. This isn't my data. I didn't write that article. See, like I was saying before, if they have any academic integrity, they're going to tell you that they just don't know. They're telling you that they make these things up. So here's the $1 million question. Why? Why are they making these things up? Well, I'll tell you why. 2 reasons. 1, for money. Right? Museums are still for money, right? No one is going to come to a museum unless you have something extravagant to put on display. So they do it for the money, right? But not just museums. Archaeologists, anthropologists, whoever, when they make these discoveries, they have to sell it. So I'm not disputing the fact that they find a bone somewhere. I'm not disputing that at all. Sure, you can find a bone. I'm disputing the fact that it's a dinosaur bone. That's what I'm disputing. Because a bone would not last 65 million years without decomposing. I've just presented data. They're conflicting each other. There are so many questions that they cannot answer, yet they present this thing as facts. It is a grand hustle. That's not a shot at T.I. or anyone. I'm just saying, it's a grand hustle. It's all about money, or at least a part of it is about money, right? If I am an archaeologist, I need money to do excavations. So someone has to provide that money. So if I got millions of dollars and I'm saying, hey, I'm going to give you this money, I expect you to come back with something that is going to be profitable, right? Otherwise, I'm not giving you any more money. There won't be any more grants for you to do your research unless you produce results. So with that being said, you see why someone would start to make up a story about what they found, why someone may fabricate what they found, because I want to keep the grant money flowing. Museums aren't going to buy elephant bones. Museums aren't going to buy giraffe bones. Museums aren't going to buy rhinoceros bones, etc., etc. So you come up with this extravagant dinosaur. Here's the other thing that you have to consider. Even if they find dinosaur bones, it still doesn't tell you what a dinosaur actually looked like. There's only so much information one can gather from skeletal remains. You don't know if the dinosaur was muscular. You don't know if it had a large fat composition. I'm talking about body type here. You don't know if it was green, orange, red, blue. None of these things you can determine just from a skeleton. Do you see how it's all just a figment of someone's imagination? You can't determine what parts of it look like because it all would have decomposed. Look, you can't grab my skeleton and say he was a black guy, he was a white guy, he was an Asian. You can't determine any of that from my skeleton. As much as they like to lie and say that you can, but you can't. White people's skulls are shaped like this versus black people's skulls. Really? I find all that to be humorous. pseudoscience at best. Here's the other reason why they come up with these theories. It's to disprove the existence of God. It goes into the evolution debate. This is why they try so hard to come up with these theories. So it's partial money and partial trying to disprove God. And what they love to say, I'm agnostic. There is no evidence or proof that God existed. And then they try and make fun of people for having faith. But isn't it somewhat the same? Right? I mean, because you're placing your faith in some man-made theory. You can't prove it. They can't prove it. So if you're going to be agnostic about God, shouldn't you be agnostic about evolution, the Big Bang theory? Just something to think about. Well, I'm going to leave it there for now. If you like the way I think, slide over to Patreon. Check out some of my original short stories. It's only $1.50 per download. If you think I'm crazy, I'll just say to you, hey, maybe I am. But thanks for watching to the end. I hope I at least gave you something to ponder. And I'll finish by saying, thanks for watching. Like always, I appreciate your time. Peace out.